Okay. Hi, everybody. Very good morning. I hope everybody is doing great. So we have good strength. I guess we have 8 of you. I will wait for just one more minute, 1 or 2 more minutes for people to join, and then we can start. Right. Okay. Right. I think we can start. We have enough people joined. Let me share my screen. Right. So we were actually doing this IUPAC naming, right? So we'll continue. We'll continue with some questions. Right. Say I have I have this compound. Go for it. Go for the naming of this. CHO, CH2, CH2, the CH double one CH, and then again one CH2. Right? So if you're done, you can put the answers in the chat box. Okay, hex 2n 1,6 al but 1 dicarbaldehyde. Okay, both of them are wrong. Okay. Right? Hex. Okay, no, same thing. Any other answers? Anybody wants to give? Both of them are wrong. Both Nikhilesh's answer and Mithin's answer are wrong. And first of all, you should not put ENE. You should put only EN, not ENE. Right? That is common mistake in both of them. Right? Any other answers? Anybody has? Like I'll again show you the compound, maybe. Okay, one more thing came. Hex 2n 1,6 dial. Yeah, that is correct. Mithun, that's right.
Thank you, sir.
Yes. Okay. So people, right? So we have two CHOs, right? Okay. So either you can start from here 1 and end with 1, 2, 3, 4, 1, 2. Okay, 1, 2, 3, 4, 5, 6, or you can start like this 1, 2. 1 second, guys. 5, 6. 1 second. Right? Okay. So now which do we choose? Like obviously, however you go, you're getting 1 and 6 for the aldehyde, right? So that is not
from the right.
8 carbon. 1, 2, 3, 4, 5, 6. Only 6 carbon atoms, right? Done.
Yes.
Okay. Right. Fine. So however you go, you're getting 1,6 for the aldehyde, right? So we have to look into the next priority. Next priority is double bond, and that also has to get the least possible number. So obviously this only will choose 1, 2, 3, 4, 5, 6 from right to left. That's what we choose. Right. Now that being done, now we know there are 6 carbon atoms. So it is hex, right? And there is a double bond in the second carbon atom. So it is going to be hex 2n. It's just a minute. Let her clean it 1 second. Okay, just a moment. I'll switch off my video 1 second, guys. Okay. So as I said, we have 6 carbon atoms, so it is hex. And in second carbon atom, we have a double bond, so it is 2n, right? And then you go for the suffix. Suffix is al, right? But you have to mention where and all also where it is present. We understand that it is 1 and 6. Both the carbon atom has aldehyde. So it is 1,6, and you have to specify the number also. How many are there? 2 of them are there. So it is going to be 1,6 dial. Right? So hex 2n 1,6 dial is what you have. All right. Okay. Next question. We have, say, okay, go for it.
So to the hydroxyl group only you have to give the first preference, sir. Than the carbonyl group.
No, the priority goes to carbonyl group.
Okay, sir.
Just once you're done, you can put down to the chat box. 7-hydroxy, oct, and 3-ine, 2,5 dione. Okay. See, the AN should not come, right? Oct is okay. 3-ine is also okay. And we have this also, right? Double bond is also there. Triple bond is also there. Right. So little modification has to be done to the name which you have given. Yes, come on, everybody should participate. Right? Take your notebooks, do not sit idle. Take your notebooks, start writing the structures. Okay, 7-hydroxy, octan, 3-ine, 6N. Okay, it's oct, not octa also, it is oct. That's it. Okay, oct, 3-ine, 6En, 2,5 dione. Okay, it is 99% right. Okay, I'll tell you what is the mistake. Okay, only Mithun has an answer, nobody else has an answer. Come on, we have 15 people in the 15 of you are there, right? Everybody should try, isn't it, people? Or will it be boring? Go for it. Any other answers anybody has? Or just you can unmute yourself and tell that this is the name. That is also fine for me. I understand. Sunday morning, like you woke up just now, just for the class. I understand, right? But still, like you have no choice, no people. As if I don't have any choice, I have to teach you. Like that you don't have any choice. That you have to listen and you have to answer the questions, right? Anyways, so this, how do we answer, right? So as we already know, obviously the priority has to be given to the carbonyl compound, that is C double bond O. So we have to start numbering from here only, no other go. 1, 2, 3, 4, 5, 6, 7, and 8. 8 carbon atoms, so we can directly write oct. Done. Now we have to check for whether we have any double or triple bond. Yes, both double bond as well as triple bond is present. Right. Now, what we have to understand is, people, we have En and Yn only as the secondary suffixes, not Yne or Ene. Right? You have to write En or Yn only. Right? And whenever you have both of them present, whenever you have a double bond also, triple bond also, you have to follow alphabetical order. Right? Alphabetical order means obviously En you should write first, then you should write Yn. Okay, right. So alphabetically, so what I can say, in the 6th carbon atom you have a double bond, so it is 6N, right? And in the 3rd carbon atom you have a triple bond, so it is 3-ine, Yn only, right? And then you understand that in the 2nd carbon atom and in the 5th carbon atom, 2,5, you have ketones, right? So we know what is the suffix, it should be on, and since I have 2 of them, so it is dione. Right. And one more thing we are missing, that is your OH group in the 7th carbon atom, that is going to be the prefix. So it is 7-hydroxy oct 6N3-ine 2,5 dione. This is the name of the compound. Right. This is the exact name of the compound. Okay. Right. Moving on. Say, people, if I ask you, if I give you this one, right? What is the name of this compound? Okay, wait, let me ask one person in particular. Maybe I will. Okay, there's something in the chat also. What happened? Yeah, Nikhilesh, 8-hydroxy. Where 8 coming? Oct 3N 7-ine 2,5. Yeah, everything is correct. How is it 8-hydroxy? I think it is 7-hydroxy, right? That alone is here to change, Nikhilesh.
Made some mistake while counting.
Yeah. Other than that, everything is correct. Almost everything is. Only the numbering is the problem. Okay, so people. Okay, let me ask someone in particular. If I have to ask, say, can I ask Akshaya? Are you there, Kana? Akshaya? Are you there, Akshaya? Yes. Okay. Can you tell me what is the name of this compound? Whatever I've written here, a cyclohexane, a ring structure with the CHO. Can you tell me what will be the name of this compound? Sorry, Kana, what is it?
Benzaldehyde. I'm not sure though.
Benzaldehyde. For benzaldehyde, we should have a ring, right? First of all, we should have a double bond should be present, or we should put a ring.
Yes.
This is not benzene, right? This is normal cyclohexane ring.
Cyclohexane.
Right? Okay, so what do you think is the name then? Okay, fine. Think about it. I'll ask someone else.
Cyclohexane.
Wait. Okay. Can I ask Anirudh? Are you there, Kana?
Cyclohexanal, sir.
Cyclohexanal. Okay, fine. So one name which we got is cyclohexanal. Okay, well, let me write the name. Right. Okay, what happened?
Sir, I messaged you in the chat box, sir.
Yeah, I saw. Right. So cyclohexanal. If you think that this is going to be name of the compound, right? People, don't forget about the structure. Okay. Now, if I give you cyclohexanal, if you forget that this is there, how many carbon atoms should be there in this compound? Can someone tell me? Cyclohexanal. Looking at the name, how
7.
many carbon atoms should be there? How many?
7.
How is it 7? Hex is what? Hex is for 6 only, right?
Yes.
Right? Cyclohexane. Cyclohex means what? 6-membered ring. That's all we have. Right? Now, we are accounting only for 6 carbon atoms, but you look at the structure, there are 6 carbon atoms plus this 1 carbon atom, totally 7 carbon atoms are there. Right? So cyclohexanal cannot be the name. Right? Okay. So how we should answer these kind of questions, right? What are you trying to do is that, what are you not able to do is that you are not able to account for the CHO, right? Or at least you are not able to account for this carbon atom. Okay. And whenever you have this kind of problems, right? There is some structure in which the CHO or say that generally only for CHO, that particular CHO is not able to come inside the chain. Right? And you're not able to account for it. You have to use the suffix differently. Okay. Now, in this case, the suffix which you have to use is carbaldehyde. Okay. In this case, only you have to use carbaldehyde when you're not able to account for the carbon. Right. So now, how do we write this, people? The correct name of this compound is cyclohexane. Okay. Cyclohexane carbaldehyde. Very simple. Right, this is the name of the compound. Cyclohexane, obviously, you are understood for 6 carbon atoms. Carbaldehyde, 1 carbon atom, totally 7. Okay, so the correct name of the compound is cyclohexane carbaldehyde. Yes, Mithin, you are right. I saw the chat box. Right, it is cyclohexane carbaldehyde. Right, now same kind of problems you will face in this kind of compound also. For example, say you have CHO, CH, CHO, CH2, CHO, something like this. Right now, if you understand it carefully, right, you will not be able to account for either, like depending on how you take the chain. For example, if you take this as the chain, you will not be able to account for it. Say if at all you take this as the chain, you will not be able to account for it. If at all you take this as the chain, this entire thing again, you'll not be able to account for it. Right. So again, however you try to match, however you try to put the numbers, you will not be able to account for one of the CHO groups. I'll write it again for you. CHO, CHCHO, CH2, CHO. Okay, right. Now, obviously, we have some problems, right? So how do we do it? Again, we have to go for this term carbaldehyde. Okay, now you can ask me, sir, for which one we have to use carbaldehyde? There is no partiality like that. For all the 3 CHOs, we have to use carbaldehyde only. Right? Okay. Now, in these kind of things, how are we going to name? You forget that first these 3 CHOs are there. Okay, you forget that these 3 are there, right? Other than that, check how many carbon atoms you have. All you have is 2 carbon atoms, right? You write that name. How you wrote here? Other than the CHO, how many carbon atoms? 6 carbon atoms, and in cyclo compound, so you wrote cyclohex. Here, other than the CHOs, we have only 2 carbon atoms. So let me write it as ethane. Okay, ethane, right? Next. Now, if at all if that's the case, we can just name this as the first carbon, second carbon in ethane. This is the first carbon and this is the second carbon, right? And ethane, we write in the first carbon, we have 2 CHOs, right? So I will write 1, 1. Okay. In the second carbon atom also, you have a CHO. We'll write 1, 1, 2, right? And we have to account for all the 3 CHO groups. So you will write this as tricarbaldehyde. Carbaldehyde. Okay, ethane 1, 1, 2 tricarbaldehyde is the name. How do you do this? You forget that the CHOs are there now. Other than that, check how many carbon atoms are there. We have 2 carbon atoms, right? So I wrote ethane, and you understand that 1, 2, both the carbon atoms has CHOs. We write 1, 1, 2 tricarbaldehyde. Very, very simple, right? Okay. Maybe we'll solve one more question like this. Maybe you will be able to do this time, right? Fine. So what if we have one CHO here and another CHO here? Go for it, people. Write the name of this compound. Okay, maybe I'll ask someone in person. Don't put, okay, I think the charts already came. Okay, great. Cyclopentan dicarbaldehyde 1,2. Is it 1,2?
1,3 should come now, sir.
1,3 is the 1,3.
Yeah, correct. Right. And it is, yeah, the E should not be there, right? This E, whatever I'm showing, it is going to be cyclopentan, not cyclopentane, right? Cyclopentan. Okay, next. This is going to be cyclopentan 1,3 dicarbaldehyde. Yeah, that is right. Right. Very easy now, people. Right. Now we have to number it like this: 1, 2, 3, 4, 5. 5 carbon atoms total. So it is going to be cyclopentan. Done. And in the first and third carbon atom, we have aldehyde. Again, you're not able to account for it. So we'll write 1,3 dicarbaldehyde. Carbaldehyde. That's it. Very simple. Right. So these kind of structures also you must be very, very, very careful. You should not write cyclopentanal, cyclohexanal, like this. You should not write. Okay, fine. Next. Now, what if I have an aldehyde and a ketone both in the same structure? Then what will you do? We'll understand. Okay. For example, if we have CH3, C double bond O, CH2, CHO, something like this. Very simple compound. Okay, right. Now you have an aldehyde as well as a ketone, which you have to give the priority. Now people understand that aldehyde has more priority than a ketone. Okay, aldehyde has more priority than ketone, right? So obviously you have to use the suffix as Al only. It has to end with Al, no other doubt, right? You cannot end with on. Right. So we know, right, whenever we have 2 functional groups in the same compound and one functional group has more priority, the other functional group has lesser priority, the one which is having more priority, for that you will use the suffix, right? And the one which is going to have lesser priority, for that you will go for prefix, not suffix, right? Okay. Now let me give you this. For ketones, the prefix can be oxo, it can be keto, it can be like any of these. Oxo or keto is fine. Okay, oxo or keto is the prefix which you have to use. Okay, now how do we write the name of this compound? Let me tell you. Obviously, the priority goes to CHO. So 1, 2, 3, and 4. No issues. So there are 4 carbon atoms. So I can directly tell it is going to be but and 1 al. No issues, because in the first carbon atom we have aldehyde. Okay, now we have to account for this alone. Now, how will you write this? 3. In the third carbon atom, we have a ketone. And what did I tell you you have to use? You have to use oxo or keto. So we write 3 oxo butan 1 al. Very, very simple. That's the name of this compound. Okay, 3 oxo butan 1 al is the name of the compound. All right. Okay, let me give you another case. Maybe let me see if we can be able to do this. Right. Say we have a CHO, and here we have a double bond O, and here we have a OH, and we have a CH3. Let me make it a little more interesting. You have a okay, put double bond. Okay, we'll put a double bond. We have a double bond also. Go for it and tell me the answer to this question. Okay, don't put it in the chat box, please. Right, I'm going to ask someone in person. Right. So this question will be answered by, okay, let me see. Neha, are you there, Neha? Yeah, are you there? Okay, I think there's some problem. Monisha, are you there? Monisha? Okay. I'm gonna write, I'm gonna remember these names, and these names, whomever are not able to respond, you should be able to give an explanation when the concerned people ask you, right? Why were you not able to reply in the class, right? Okay. So, okay. Anirudh, I asked you last question. Are you there, Anirudh? Anirudh, are you there? Okay, I don't know what is the issue. Right. Nanda, are you there, Kana?
Yes, sir.
Yes, sir.
Yeah. I got 2S. Who and all tool, I don't know.
Sir, there's another Nanda, sir.
Oh,
Deviation.
there's Nanda Kishore. Okay, okay. I'm asking Devanesh Nanda. Okay. Devanesh only, right? The name is?
It's deviation.
Oh, Devesh. Okay. Devesh Nanda. Right? Are you there? Okay. The name, okay. You are only talking, right? Yeah,
I'm
please. Can
doing
you?
it, sir.
Yes, Kana. Okay. So can you name this compound? Right? Take
one
some
second.
time.
I'm doing
Yeah.
it.
Yeah, and you can put it in the chat box. Okay.
Okay.
Yeah. Good. Good. And 1 second, people, and I'll be back by the time once you answer the question. Okay. There's something in the chat. You're not getting it. Okay, no issues. At least you tried. Good attempt. Good attempt, Nanda. No issues at all. Right. Fine. Let me help you here. Right. So obviously the first priority of all of these groups goes to CHO. Right. And obviously second priority has to go to keto. Right. So we should start numbering like this only. 1, 2, 3, 4, 5, and 6. Right. Okay. Now let us write the suffix part first. It is going to be cyclohex. Right. Now we cannot put cyclohex and because we have a double bond. And where do we have the double bond? In the 4th carbon atom, you have a double bond, right? So it is cyclohex 4N. Done. Okay. Now in the first carbon atom, you have an aldehyde, but again, you are not able to account for it in the main chain itself. So you write cyclohex 4N carbaldehyde. Done. Okay. Cyclohex 4N carbaldehyde, because it is going to be in the ring structure. Now you're not able to account for it in the main chain. Okay. Other than that, we have this ketone, OH, and a CH3. Right. So what are the prefixes you have to use? Oxo, hydroxy, and methyl. 3 things you have to use. And whenever you have 3 things like this, 4 things like this, more than one thing you have, you always have to follow alphabetical order. right? So obviously H will come first, then M, then O, right? So we'll first put a hydroxy first, that is there in the fifth carbon. So we write 5-hydroxy, done. Then comes methyl because that is having M, that is there in the sixth carbon atom, 6-methyl. And in the third carbon atom, you have ketone, that is oxo, so it is 3-oxo. That's it, right? 5-hydroxy, 6-methyl, 3-oxo, cyclohex, 4N carbaldehyde. 1 carbaldehyde, if you want to mention, you can mention, but it is understood, carbaldehyde, right? This is the name of the compound, right? This summarizes everything, whatever we have studied till now, right? I think someone got the name, someone answered, right? I'll check whether it's correct or not. 2-methyl, 3-hydroxy, 5-oxo, cyclohex, 3-methyl. No, that's wrong method, right? We have to use carbaldehyde, right? Okay, so this is the exact name of the compound. Right? I hope everybody is able to see. These kind of questions are not going to be asked to you, don't worry. Okay, but these are all the this is the most toughest question, not say, at least for your level, for the school level, if after all they want to ask you a very, very, very tough question in IPAC naming, these kind of things they can give, but 99% you are not going to get any of this. Don't worry. All right. Okay. With that being said, that is about the IUPAC naming of aldehydes and ketones. Done, people. Now what we'll do, we will study about one of the most interesting part in this isomerism. We already know, right? In isomerism, there is going to be one beautiful isomerism shown by aldehydes and ketones. Okay, and that is tautomerism. Okay, that is what is called as tautomerism. Okay, now we have seen so many isomerisms like structural isomerism, stereo isomerism, chain isomerism, functional isomerism, so on and so forth, right? But out of all those, tautomerism is actually a very special one. Right? Tautomerism is actually a very, very special isomerism. Why is it so special? Right? For example, right? Let us take some examples. Like say I have CH3, CH, OH, CH3. Okay, and I have CH3, CH2, CH2, OH. Okay, right. Now this is propan 2-ol. This is propan 1-ol. Right, isomers, question isomers, all molecular formula same. Only the difference is there in the where the OH group is present. This is there in the second carbon. Here it is there in the first carbon. That's the only difference. Right. Okay. Now what we have to understand is, for example, say I have a test tube. Okay, I have a test tube in which this molecule is there. Okay, I have a test tube in which this molecule is there. That is propan 1-ol is there. Okay, now is there any possibility by which propan 2-ol can also be there in this? What I'm trying to ask you is that, is it possible for this molecule to convert to this molecule, or say is there a possibility for this molecule to convert to this particular molecule? Right, the answer is no. Right? If at all you have a test tube containing this, only this will contain. There is no chance that not even a slightest chance that this molecule can also exist along with this molecule. No, that will never happen. Right? But if you have tautomers, right? If you have tautomerism happening, right? The particular isomer and the particular compound and its isomer can coexist. That means what? One isomer can convert itself into another isomer, and in the test tube, you will see both of them present. Right? That is the speciality of isomerism. That is the speciality of tautomerism. Tautomerism is the only isomerism in which the isomer will be able to convert itself into another isomer. Right? But in no other isomerism, we will be able to draw the structure. Yeah, for a given molecular formula, we can write this, we can write this. All this can be done on the paper. Right? But will you be able to, will the molecule be able to convert itself into another isomer? No, that cannot happen. That can happen only in the case of tautomerism. Right? Very, very special tautomerism. Very, very special because of that. Right? The isomer, one tautomer is the isomer. Right? One tautomer can convert itself into another tautomer by some means. I'll tell you how and what is going to happen. All those things you'll understand. But this is the reason why tautomerism is very special. Tautomerism is the only isomerism that is going to happen in reality. Right? One compound will convert itself into another compound. Isomer. Right? Okay. Now, in our syllabus, as we're talking about this particular chapter, we have something called as keto-enol tautomerism. Right? We have something called as keto-enol tautomerism. right? Okay, from the name itself, you can understand, right? Tautomerism is actually a type of functional isomerism only, right? Tautomerism is actually a type of functional isomerism. We know what is functional isomerism. Same molecular formula, but different functional groups, right? Same molecular formula, but different functional groups will be there. That is what is functional isomerism. Here also it is functional isomerism only, right? But except that that particular isomer can convert itself into the another functional group, right? So from the name you see, keto means ketone or aldehyde, okay? Ketone or aldehyde, and enol. What is enol? C double bond C with a OH. That is what is an enol. Enol, right? So keto enol tautomerism means the aldehyde or ketone can convert itself into its enol form, or say if you have an enol form, you will be able to convert it back into the keto form. Okay, so that is what you're going to study. How are you going to convert it? What exactly is happening? We'll try to understand now. Right now, the reason for tautomerism to happen in aldehydes and ketones, right? Why is it happening? Right? It is because aldehydes and ketones have a special property. Right? What is the special property? The special property of aldehydes and ketones is that they have acidic alpha hydrogens. Right? This is the reason. This is the reason behind why aldehydes and ketones can show tautomerism. Right? The reason for aldehydes and ketones to show tautomerism is because they have acidic alpha hydrogen. Means what? What is first alpha hydrogen? For example, people, I have CH3, CHO. Right? Am I talking about this hydrogen? People, am I talking about this hydrogen is acidic? Is it correct? I'm telling you that this is the alpha hydrogen. True or false? Which is correct. This particular hydrogen attached to the aldehyde is the alpha hydrogen. True or false?
True,
Sir.
Okay, right. People, we have to understand, first of all, what is an alpha carbon? An alpha carbon is the carbon which is attached to the functional group. Attached to the functional group. Right? For example, if I say CH3, CHCl, CH3, this particular carbon which is attached to the functional group, that is what is their alpha carbon. Right? Same if at all I had OH here. Again, this would have been the alpha carbon. Alpha carbon is the one which is attached to the functional group. Right? Here, what is the functional group? This entire thing, CHO, is the functional group here. Right? So the carbon atom attached to it, this is your alpha carbon. Please be very, very careful. Right? What is alpha carbon? Alpha carbon is the carbon which is attached to the functional group, or which is having the functional group. Right? So we understand this CHO entire thing is the functional group to that which carbon is attached. This carbon atom is attached, so that is your alpha carbon. Right? And obviously the hydrogen present in the alpha carbon is what is called as alpha hydrogen. Very simple, right? The hydrogen present in the alpha carbon. In this case, you have three alpha hydrogens are present. Right? The hydrogen atoms present in the alpha carbon is what is called as alpha hydrogen, right? So in this case, we have 3 alpha hydrogens. Please understand, this is not the alpha hydrogen, right? You always have to check the carbon atom which is attached to C double bond. In this case, it is this carbon. Okay, so what are we trying to say? We say that the aldehydes and ketones are able to show tautomerism is because these alpha hydrogens are marking, right, are acidic. That means they can come out as H+. Okay, now how do I prove this to you? Right. Now, people, in organic chemistry, how do we tell something is an acid or a base? I mean, how do we tell that that particular thing is a good acid, that particular thing cannot be an acid? How do we say that? We say it like this.
Oh.
The acidic strength, right? The acidic strength of any organic compound in general, right, is directly proportional to the stability of the conjugate base. You must have already studied this in your alcohols chapter, because alcohols are also acidic, right? We say that primary alcohols are more acidic than secondary. Secondary is more acidic than tertiary. Why? Because of this particular criteria, stability of the conjugate base, right? More and more the conjugate base is stable, more and more will be the acidic strength. Right? Okay. We know what is conjugate base also. After removing H+, whatever is remaining is what is called as conjugate base. Right? For example, if I have HCl, if I remove H+, whatever is remaining, Cl- is what is the conjugate base of the acid HCl. This is the acid. This is your conjugate base. Okay, after removing H plus, whatever is remaining in the acid is what is called as conjugate base. Okay, now in organic chemistry, after you remove the H plus, you make the conjugate base, and somehow if you can prove the fact that the conjugate base is stable, then I can tell that that particular thing can behave as an acid. Very simple. Okay, so if I can make sure that CH3C double bond OH, this particular hydrogen, if it is removed, any one of the hydrogen, if it is removed, right, can I write that minus H plus? Any one of this is removed. So can I write this as CH2 minus C double bond OH? Is it not? I removed H plus, obviously this is the negative charge. So this is my conjugate base, right? So if I can prove that this conjugate base is stable somehow, and I can tell that definitely this H plus can come out, right? And don't you see that this carbon ion, or say this conjugate base, is actually resonance stabilized, people. This is actually stabilized. How can I do the resonance structure now? I can write this as CH2 double bond CO minus and a H. Right? What happened? This came here, made a double bond. Obviously, the C double bond cannot be there because this carbon now will have 5 bonds. So you break one of the pi bonds. That's it. This is the resonance structure. Right? So this is actually happening. After you remove the H plus, this conjugate base is actually getting stabilized by resonance. So definitely this is a good acid. Right? Now what do? You remove the H plus, right? Here. Now you add the H plus to this. Where will you add the H plus? Obviously, wherever you have a negative charge, that is to oxygen, right? So can I write this as CH2 double bond COH and H, right? Now, can't you see that this is nothing but your enol form? You have a C double bond C, and that is having an alcohol, enol, and this is nothing but the keto form, or the generally we say keto form, it is an aldehyde in this case. Right, keto form, and this is your enol form. So this transformation actually happens in reality. Why? Because we know that the alpha hydrogens are acidic, right? So you remove alpha hydrogen, make the conjugate base, write the resonance structure, make O minus, and to that O minus you add the removed H plus, right? You are going to end up in the enol form, right? This particular thing, whatever I showed you now, is what is called as tautomeracy. More specifically, keto enol tautomeracy. Right? Okay. Now, if I give you, say, the keto forms, you should be able to get the enol forms like this. Okay, remove H plus, draw the resonance structure, get the enol form. Right? Okay, I'll give you one more example. Then the next example you will do. Okay. Say, I have, for example, CH3, C double bond O, CH3. Okay, right. Now, please understand, this is one alpha position. This is another alpha position. You should not say this is alpha. Right, the carbon atom is attached to the functional group. In this case, 2 carbon atoms are attached to the functional group. So both these are alpha carbon atoms. So any one hydrogen you can remove. There is no restriction here. Okay, any one hydrogen you can remove. Right. So I remove minus H plus. So I'll remove this particular hydrogen. Okay. So how can I write this? CH3 C double bond O CH2 minus, because I removed H plus from this. So it is going to become CH2 minus. Then what do you do? Draw the resonance structure. This negative charge will come here, make a bond, and one of the pi bond breaks. So what will you have? CH3 CO minus double bond CH2, right? Then what do? You add the H plus to the oxygen minus. So you will get CH3 COH CH and double bond CH2. That's it. This is your enol form. This is your keto form. Right? So again, same exact thing I did. Remove the alpha hydrogen, right? Make the conjugate base, draw the resonance structure, and you add the OH plus back again to the O this time. So it is going to become an enol. Very, very simple. Right? Okay. Right. Now, if I give you one structure, will you be able to write? Right? If I give you, okay. Now, one more thing, people. If I ask you like CH2 double bond CH, C double bond O, and a CH2. Right? Okay. Now again, you have 2 alpha positions. This is one alpha position, this is another alpha position. But please understand, you cannot remove hydrogen from this. Why? Because this is going to be an sp2 hybridized carbon. You cannot remove hydrogen from a sp2 hybridized carbon. You can remove only from this. Okay. So now if you have 2 choices like this, right? But one choice is gone. right? You cannot remove hydrogen from a sp2 or an sp hybridized carbon atom. You can remove only and only from sp3 hybridized carbon atom. People, be very careful, right? Okay. Now that being said, can you write the enol form of this? Please go for it, and you can send me the picture in WhatsApp. Right. Once you're done with the enol form, you have to show me all the things: removal of H plus, resonance structures, and at last the enol form. Everything has to be shown. Okay. Now you know that this hydrogen cannot be removed. Only this hydrogen is possible. Right. Now go for it and show me the enol form. You can send me in WhatsApp. Just exact same thing, no difference. Right? Everybody, please take your notebooks. Please do not sit idle. Take your pen and start writing the structures. And you can send me in WhatsApp once you finish.
Sir, I sent it.
Okay. Correct. But you have to show me the steps, all those steps. You got
For
the
the
final.
reactional steps, sir.
Sorry?
The steps that take place for this to come to this final product.
Yeah, like basically you have to show the removal of H plus, the resonance structures, and at last you have to show the enol form. You have shown the enol form correctly, right? But
Okay,
you have,
sir.
you have to show me the steps also, all the steps. How is it formed? Another photo came once again. Okay, you remove the H plus, make O minus is missing. Whomever sent this side, who sent this now? Can I know who sent this? 98418. Who's that? Guys? CH2, CH. It's better you send me the structure in WhatsApp, Nanda, Devesh. Oh, Venisha. Okay, Venisha. The only difference is in the third, first, second, third, in the resonance structure. After you write the resonance structure, there should be O minus. You just written O. Right? The bond breaking you're showing, right? C double bond O is breaking. So you have to go for this thing. O minus you have to show. And everything is correct. Yeah, the structure is correct. That is the only difference. Okay, another picture came. Okay, that go O minus, you add H plus. Yes, good. I think this was, who's this?
Nanda Kishore, sir.
Sorry?
Nanda Kishore, sir.
Oh, Nanda Kishore. Okay, Nanda Kishore. Yeah, yours is right. Okay, yours is correct. Very good, very good. Right. So, Venisha, yes, Venisha. Good. Right. So, people, I think you understood now. Right. So, what do? You remove a H plus from this. Right. You cannot remove H plus here. You have to remove H plus from here. So, you will write CH2 double bond, CH, C double bond O, CH2 minus. Yes. Okay. Now, you write the resonance structure. This will come and this bond is going to break. The C double bond O is going to break. So we write CH2, CH, CO minus. You have to show the minus here, right? And then the double bond CH2. And at last, what will you do? You will go for adding a H plus to the oxygen. So you will write CH2, double bond CH. Any other thing? Okay? Yeah, one more. Okay, I think it's Rohan's. Okay, Rohan is correct. Then steps are also right. Okay, so now you add a H plus to this oxygen, right? So you will have COH double bond CH2. This is your enol form, and obviously that one, the first one, whatever we show was the ketone form, right? And whomever has sent it correctly. Very good, very good. Right now, one last question in this ketone and daughter medicine, because you are going to get amazed, okay, with the thing which you are going to get. Right, so we have this one, we have this, and we have this. Okay, now go for it, people. Right, tell me what is going to be the enol form. Show me the steps. Go for it. Now again, this is one alpha carbon. This is also an alpha carbon. You know where you should remove from. Right, you cannot remove from here. Right, you understand that there are two hydrogen atoms here, no doubt. Right, you can remove any one of them and go for it. Same thing again. Finish it and send me in WhatsApp. Okay, and you are going to get a very familiar structure which you already know. Still now no response came. I don't know what is making you feel so difficult.
1 minute.
Okay.
So I sent.
Yeah, got it. O minus. Okay. Done. OH. Yes. What is this compound? Rohan? Last compound. Which you got? Huh?
C0.
Yes. Correct. you are actually going to get phenol. Okay, yeah, correct. Who is this? I don't know. Akshaya. Okay, yeah, Akshay, you're also right. Okay, so people, is very simple. You are going to remove this particular hydrogen, right? Or you remove a H plus minus H plus, right? So now how do you do this? We have already two double bonds, right? Now we have a negative charge on this carbon, right? And we have a double bond also. Now what are you going to do? Same thing. Make the negative charge, make a double bond here, and this bond is going to break, right? So now what will you have? We will have one double bond here and one double bond here, another double bond here and a O minus, and then you add the H plus. So what are we going to get? One double bond, second double bond, third double bond with the OH. That's it. We are actually going to get phenol. Right?
So actually, this resonance structure, right, forms as a.
What kana?
It's similar to resonance, right?
Yeah, it is. It is not similar to resonance. It is resonance. It is exactly resonance only.
Okay.
Right? Okay. Fine. So yeah, these are all the things you have to know about keto-enol tautomerism. How do you convert a keto form into an enol form? Okay. And the same thing actually you will be using it in some of the mechanisms also when you're going to. And now we are going to go for the now we are going to go for the chemical reaction part. Right, so many times you will see that this keto-enol tautomerism will come into the picture. Okay, right, I'll show you to you at that time. Right, fine. Now that is the say we have completed IUPAC naming, we have completed physical properties. Now we have completed tautomerism also. Three good things are completed. Right, now what are we going to do? We are moving on to the chemical reaction part. Right, now this is where it starts. We are going to go for preparation. Okay. Right. Now there are methods, there are preparation methods by which you will be able to produce only aldehyde no matter what, right? And there are reactions where you can produce only ketone no matter what. And there are methods by which you will be able to prepare both aldehyde as well as a ketone. Okay. Now we will first look into the methods by which you will be able to prepare both aldehydes and ketones. Preparation of first one, both aldehyde and a ketone. Right, any of these things can be produced with the same method. Right, okay. Under this, the first one is from alkenes. Okay, from alkenes, we are actually going to produce aldehydes and ketones. Can you guess? You already know this reaction, right? By doing what? If at all I have a C double bond C, right, and I wanted to convert it into aldehyde or ketone, do you remember any reaction?
Acid catalyst.
Acid what?
Acid catalyst.
Acid catalyzed hydrolysis. Yeah, if I go for H plus bar H2O, what am I going to get? I'm going to get H like this, and I'm going to get OH. Alcohol you will get, right? So no, this is not the case.
We can do ozonolysis, no, sir.
Absolutely, yes. We can go for ozonolysis, people. Right, from your 11th class, I don't know if you studied with me, I gave you a shortcut to remember ozonolysis, how you're going to get how you're going to form it. Right, wonderful. So from alkenes, we are actually going to go for ozonolysis to produce an aldehyde or a ketone. Right, what do? We have a C double bond C, right, and we have to go for ozone O3, zinc and H2O or H2O2, depends on what conditions you have. Right, zinc and H2O2 or H2O2. Right, people. Now, what is the shortcut? You remember the shortcut, right? We have wherever you have a double bond, you break the double bond. Okay. And instead of C double bond C, you put C double bond O and C double bond O like this. So what are you going to get? One, this, you remove the carbon and you put oxygen. Same way you do for the other carbon also. Another carbon is there, which is having the C double bond O with other two bonds. Very, 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 very simple. Okay. Now you are seeing, right? You're actually getting carbon compound. An aldehyde or a ketone, depending on what are the two other bonds, right? Depending on what are the two other bonds, you will be able to get an aldehyde or a ketone. Good, right? So we'll take some proper examples. Say if at all we have CH2 double bond CH2, and I go for ozonolysis. Now what we do? Break oxygen, oxygen. What do we get? We get it's like HCHO. Is it not, people? Right? This is like what? This is like C with 2 H right? C with the 2H, and you have a double bond group. That's it. This is what? This is nothing but methanol, formaldehyde, whatever you want to call it, and 2 moles of the same compound. This is going to form 1 HCHO. This is going to form another HCHO. That's why you wrote 2 HCHO, right? Okay. Now another example, say CH3, CH double bond C, CH3, CH3. If you have something like this, right now what we do? Same thing. Go for ozonolysis. Ozonolysis, zinc and H2O2, break it and put oxygen. Now this part is going to form what? CH3CHO. Done. This part, and this particular part, can I tell, is going to form, say I start with this CH3, C double bond O. This is going to have C double bond O, and I'm going to have another CH3. Now what are you forming? You're forming one aldehyde, another ketone. Wonderful, right? Right? Just by simply going for a ozonolysis, you'll be able to convert an alkene into an aldehyde or a ketone, depending on what kind of double bond you have. Right? Okay. Now, you do something. Okay. Right. Now, I'm going for a cyclo compound. Okay. Let me draw this again. Okay. I have a double bond here. Go for it, people. I want to know what is the ozonolysis product. Nothing changes. Okay. The same trick will help you here also. Go for it. Right, and tell me, and you can send me the answer in WhatsApp. You can click a picture and send me in WhatsApp, whatever you get. Same thing, just wherever you see a C double bond C, break it, C double bond O, C double bond O. That's all you have to do. I don't think it's that difficult. This much time. No answer still now. Guys, I hope you're doing. Please don't sit idle. What do you have to do? Okay. Let me help you in this next thing. Anybody needs time? Anybody is still doing and they need more time? Or can I do this now? Okay. I suppose nobody needs time. Okay. So we understand that there is one hydrogen here, there is one hydrogen here. No worries, right? Now what do we do? Same thing. Break this oxygen, done. Now you start with this carbon. Okay, whatever the carbon I'm marking, now you start with this carbon. Now that carbon has a hydrogen, okay, and that is also having a C double bond O. Done. Okay, now go for the next one. Next one is CH2, 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 4 CH2s, 4 times. Okay, now coming to this particular carbon, whatever I'm marking, right? Now that carbon has a hydrogen, and that is again going to have now what? C double bond O. Now what you have here basically CH2, CHO, CH2 4 times, CHO. Done. Very simple, right? Like, I did not do anything extra. All I did is I broke the double bond, C double bond C, and I put oxygen on both sides. Very, very, very simple. Right? Will you try one more? Okay. Look at this. Say, now what if, interesting. I'm going to give you an interesting thing. CH2 double bond CH, CH2 C, CH3 double bond CH, CH3. Okay, right? Now you have two double bonds here, people. O3, zinc, H2O2 or H2O, whatever it is. Right? Now you have two double bonds here. Do it 2 times. Go for it and tell me the answer. And you can send me in WhatsApp. So you have two double bonds, break both the double bonds. I hope you guys are doing. Please do not sit idle. Work it out. You are going to get the answer. Now, no, till now, no answers. I am really thinking that you guys are doing nothing. You guys are not even trying. Fine. So it's again, we're going to be very simple. You break this double bond, put oxygen, oxygen, break this double bond, put oxygen, oxygen. That's it. Now what is going to happen to this part? This part, can I tell, is going to form HCHO. Done. Two carbon and two hydrogen, one C double bond O. Done. And what about this particular part? Now this becomes a chunk. Right? Now this part is going to happen like this. C double bond O with the H. Right? I'm talking about this carbon with this oxygen here. And then what you have? CH2. Right? And you have this particular carbon having a CH3. I think something I'm missing. Yeah, okay. Right? So this particular carbon is now going to have a C double bond O, and that is also having a CH3. Done. Now this is the second chunk, this chunk. Okay, now the third chunk is again going to be very simple. This chunk, we start with this CH3 and you have a C with the H, right? This one, and again, that is having a C double bond O. What are you getting here? Basically, this is nothing but CH3, CHO. Done. So you are going to get 3 different products like this. Okay, right? I hope everybody is getting it, right? So we break it, put oxygen. It's very, very, very simple trick. Very simple trick. Right? Okay. One more question. Let us see if you can do this. For example, if we would have had a double bond here. Okay, now these are 2 cyclohexane rings sandwiched. Okay, and in between that you have a double bond. Okay, go for it. And tell me what is the answer that you will get. See, I'm giving you so many interesting questions, and if you're not going to try you're going to lose the benefit. That's how it is. The loss is yours. Again, the same trick, or the exactly same trick. I hope you have done it, right? So again, the same thing, only break this, put oxygen, done. So we have something like this, and this particular carbon, whatever I'm marking is this particular carbon, and that is going to have a C double bond O, because the C double bond O is coming onto this carbon, right? This carbon, right? Then continue. Okay, then you have this, everything same. Again, if I mark this carbon, that carbon is having the C double bond C. Now that is going to have a C double bond. This is the structure which you do. See, the structure looks complicated, but the thing which you have to do is very simple, right? You have to break the C double bond C and put C double bond O. That's it to both the carbon atoms. Very, very simple, right? This is the final answer which we get. Okay, right? So people, I think we'll stop with this for today, right? We'll continue next class. We have so many reactions to see. Like from next class and all, it is going to be pure only reactions, only reactions, right? I have something in there, a chat also. Oh, yeah. Oh, my number. Okay, my number is this. Okay, my number is 8939219916. Okay, that's my number. 8939219916. You can save it, right? Okay. So I think that's it, right? So we'll stop this for today, right? Any questions anybody has? Want to ask me? Okay, fine, people. Thank you so much. We'll meet again next week. I'm ending the class.
Thank you, sir.
Thank you.